Hello friends, very good morning. In this video, we are going to learn about the projections of a triangular lamina which is isosceles in nature, and the dimensions of this are given to be 30 mm and 65 mm. And friends, let's see what is the question we have for today's video. The question reads like this: an isosceles triangle having base 30 mm and height 65 mm rests on xy. Xy is the line of intersection of VP and HP. And with base, with the surface inclined at 40 degrees to VP. Draw the three views of and measure the inclination of the surface with HP. Friends, this is the triangular lamina we have got. And here friends, they have given us the base which is measuring 30 mm and the height measured from the center of the base to this is 65 millimeter. And friends, you know very well that these two angles are the same. So what do? We just place this lamina on VP, on the vertical plane. That is, in this case it is the board here. Write down the front view, an isosceles triangle of 30 by the height 65, and the end view, when you see from the left, it is going to be a line on this x1 y1, and x1 y1 is the line of intersection of VP with the right profile plane. And friends, in the top view, if you observe like this, you are going to get a line on the xy. So friends, this is how we commence the problem. So I will construct a triangle having base 30 mm, that is, this dimension is 30 mm, height is equal to 65 millimeters. So I'll just mark it as 65 here, the height of the triangular lamina is the 65, this side is equal to 30 millimeter. I'll show here this as 30. And friends, we will number these corners as A dash, B dash, and this is C1 dash. I'll write down because the position of this is going to change when it is going to make an angle with the vertical plane. Like this it will become. So we will just call this as C1 dash, and the corresponding points in the end view will be, this is going to be C1 double dash. This point AB or this line or the edge AB which is on XY remains at the same location both in the top view and front view, and in the end view you are going to get it here. I will call this as A double dash B double dash. This is C1 double dash. I have shown all these in thin lines to start with because this is the initial position of the lamina when it is resting on VP on its surface. Friends, now what does he say? That the surface is inclined at 40 degrees to VP. Friends, you can see here, this is the lamina. The surface is at an angle of 90 degree here. So this is perpendicular to what? Perpendicular to the XY line. Now, it has to be at an angle of 40 degrees to VP. Friends, when the surface makes an angle of 40 degrees with VP, in the front view, the height of the triangle gets reduced. In the end view, whatever the line you have got here, now it takes up this position with this surface making an angle of 40 degrees with the VP. So what I do, I take this A dash B dash as center and radius equal to this vertical height, which is again equal to 65. I am going to draw an arc. So friends, I have written an arc. I will repeat again. Taking center A dash B dash, height or the radius equal to this 65 millimeter, I have drawn an arc to intersect the line drawn through this point at an angle of 40 degrees to VP. And friends, this line will finally represent the end view, and I call this as C double dash, and this is A double dash B double dash. This is how the lamina looks in the end view. And friends, remember here, when this is making an angle of 40 degrees VP with the HP, it will make an angle of 50 degrees because the vertical plane and the horizontal plane are at an angle of 90 degrees. So this will be 50 degrees. That is asked in the question. Determine the inclination of the surface of the lamina with the HP. Friends, this is the final end view. I will call it as LEV. And this left end view is obtained on the right profile plane. Now friends, as I told you, this is going to move towards the observer, and now this C1 dash comes down, and let's see how to obtain the corresponding C dash. Friend, from here you can write a horizontal line to and a vertical line from there. Now this is going to be the final front view. I am going to show it as A dash C dash. So I will just join these friends. This is the other line. So this is the base, and friends, we are getting the final front view, that is A dash, B dash, C dash, and AB will be here only. This point is A, this point is B, because that edge AB is on XY, and hence it is seen both in the top view and front view on XY. That we can see here, A dash, B dash and AB are on the same line. Friends, you have the front view, the triangle A dash, B dash, C dash, and you have the end view A double dash, B double dash, C double dash, which is making an angle of 50 degrees with the HP. Now friends, after this, I have to obtain the corresponding top view. Friends, it is very simple. This point is fixed AB, the edge will remain here only. Now I have to locate the point C in the top view. Write a vertical line from there. To meet the 45 degree line here, write a horizontal line from there to obtain the point C on this. So I will just write a thin line through this. It will come exactly in the center, and this point will give you point C. So friends, if you join AB, BC and CA, it will represent ABC, the top view, which I have to show by visible lines and as a dark line. Friends, this triangle will give you the top view of the lamina, and this is the front view, FV, and this is the left hand view of the lamina, which is seen as a line, and that is obtained on the right profile plane. Friends, this is how we have completed the complete projections, including the front view, top view and left hand view of the lamina. Friends, please go through the complete video without skipping any part of the video in between. And if you like this video, please share the information about this video with all your friends. Thank you for watching my YouTube video. Have a blessed day.